We often look up at the stars or just think about how things work, and, well, the sheer complexity of the universe can be overwhelming. It makes you wonder if there's one single idea that could explain it all.
It's a really powerful drive, that search for unification.
Exactly. And today, we're diving into something that, for a while, seemed like it might be just that. M-theory. Stephen Hawking even called it potentially the ultimate theory of the universe. That's quite a statement.
It really is. And to see why it was so revolutionary, you kind of have to picture the physics landscape before it came along.
Right. What were we dealing with then?
Well, fundamentally, you had two titans, two incredibly successful theories. First, there was Einstein's general relativity.
Ah, the big picture stuff.
Mhm.
Gravity, planets, galaxies moving apart, that sort of thing.
Precisely. It described the large-scale universe beautifully, but you had quantum mechanics.
Okay, so the polar opposite, the world of the incredibly small atoms, particles, photons.
Exactly. And quantum mechanics is, well, weird. Probabilities, uncertainty. Very different rules than relativity.
And the core issue was they just didn't work together.
That's the crux of it. Both were incredibly accurate in their own realms, relativity for the massive, quantum mechanics for the tiny. But try to combine them, say, to describe gravity at a quantum level. They completely broke down, gave nonsensical answers.
So a major roadblock. How did physicists even start thinking about bridging such a huge gap?
Well, that's where string theory made its entrance. It was a radical idea.
Radical how?
Instead of imagining the fundamental bits of reality as, like, tiny points, string theory suggested they were actually minuscule, vibrating loops or strands of energy, strings.
Vibrating strings. Okay,
Yeah.
so like plucking a guitar string gives different notes.
That's a great analogy. Yeah, think of it like a cosmic symphony. The idea was that different ways these fundamental strings vibrate correspond to the different particles and forces we see. A specific vibration might look like an electron, another like a photon, another like a graviton.
Huh. That does sound quite elegant, actually. A way to get all the diversity from one basic thing.
It was elegant, but there was a catch, a pretty big one initially.
Which was?
It turned out there wasn't just one string theory. Physicists discovered 5 different consistent versions.
5. That doesn't sound very unified. Which one was supposed to be right?
Exactly the problem. Having 5 contenders for the theory of everything was, well, confusing. It felt like maybe we were missing something bigger.
Okay, so enter Edward Witten in 1995. What was his breakthrough?
Witten delivered this landmark talk suggesting that maybe these 5 string theories weren't fundamentally different after all.
How so?
He proposed they were actually just different facets, different perspectives, you might say, of a single deeper theory, a theory that lived in, wait for it, 11 dimensions.
11. Not the 4 we experienced, 3 of space, 1 of time.
Nope. 11. Our familiar 4 plus 7 additional spatial dimensions curled up incredibly small, so small we don't perceive them directly. And this bigger framework encompassing the 5 string theories he called M-theory.
M-theory. Okay. 11 dimensions. That's already hard to grasp. And it introduced something else too, right? Brains.
That's right, brains. Short for membranes. Think of them as higher dimensional surfaces or sheets existing within that 11-dimensional space or bulk.
Membranes.
Yeah.
So what do they do in this theory?
Well, one really mind-bending possibility is that our entire observable universe, everything we see, touch, measure, might actually be confined to one of these brains. Like we're living on a giant sheet floating in a higher dimensional space.
Wow, okay. Our universe on a membrane in 11 dimensions. It sounds like something straight out of science fiction.
It does, but it comes from some very sophisticated mathematics trying to reconcile those fundamental conflicts between gravity and quantum mechanics.
And it leads to a pretty profound question, doesn't it?
Well-
If our universe is on one brain,
Could there be others, other brains, potentially other universes, existing parallel to ours in that higher dimensional bulk?
that's the implication. M-theory opens the door to the idea of a multiverse, not just as speculation, but as a potential consequence of the underlying physics.
Exactly. Countless universes, maybe just beyond our perception, existing in dimensions we can't directly access.
So we went from 2 conflicting theories to vibrating strings to 5 string theories, and then to M-theory, suggesting they're all part of one 11-dimensional picture with membranes potentially holding entire universes.
It's quite a journey, conceptually.
It really makes you think, doesn't it? If our universe is just one brain among potentially many, what does that really mean for us? For our place in the grand scheme of things, that's definitely something to ponder.